This next one, we'll be solving more word problems today. The different two types of problems we're going to be solving are things with things and total price. So again, we're going to set up those x and y variables, and we'll write them down. We'll figure out which one's x, which one's y. We'll set up the two equations and either use substitution or elimination, and we'll answer the question. The things types of example is something where I'm buying two different items and they cost two different prices, and we have a total price. So example 1 and 2 are like this. So example 1 looks like this. What I have here is I'm going to denote pencils as x, and I'm going to denote pens as y. Since they both start with P, I'll just use x and y. So the pens are y, and the pencils are x. So what I want to do is I want to go ahead and write down my two equations. I've got 5x plus 2y equals $2.75. And then here I have 5y plus, I've got 2x equals $3.20. Now, if I really wanted to, I could get rid of all these decimals by multiplying everything times 100, or moving my decimal over 2 spots. That would give me 500x plus 200y equals 275. I'm really okay just dealing with the decimals, and I'll just use my calculator as necessary, or as needed. And I'll bring that up so you guys can see and make sure that you're entering things in properly. If you notice, elimination would work out great, but nothing falls out right away. So what we're going to do is I'm going to flip-flop these coefficients. I'm going to multiply this top one times 2, and multiply the bottom one times 5, and actually I'm going to make it a negative 5. That way I have a positive 10x and a negative 10, and those x's will fall out. So I'll end up with 10x. Let's go ahead and write it over here to the side. I end up with 10x plus 4y equals 275 times 2. That's $5.50, or 5.5. Down here I have negative 10x plus negative 25y equals $3.20 times negative 5 is negative 16. So now these eliminate, and I end up with negative 21y equals negative 16 plus 16 negative plus 5.5 is negative 10.5. Then what I'll do is divide by negative 21 on both sides. Divided by negative 21 gives me 0.5, or 50 cents. So y is 50 cents. Well, that means that my pens, which were y's, are 50 cents each. Now I'm supposed to figure out the price of the pen and the pencil, so I need to take that value and plug it back in for the first equation. The pens are the y values, so I'm going to do 5x plus 2 times 0.5 equals 2.75. 5x plus 1 equals 2.75. Subtract 1 on both sides. 5x equals 1.75. And then divide by 5 on both sides, and x is 35 cents. So that means my pencils cost each 35 cents. My next example, I will not get through the entire thing, but I will go ahead and set up the problem. Says the math club spent $135 buying 6 cases of juice. So I'm going to use J for juice, and I'll use W for water. 1 case of bottled water. So they spent $135 buying 6 J's plus 1 case of water. The science club spent $110 buying 4 cases of juice and 2 bottles, or 2 cases of water. How much does a case of juice and how much does a case of bottled water cost? So again, I'm going to be using elimination to solve this, and I will continue this with the next video. Alright, so I had just written down my 2 equations. Now I'm getting ready to use elimination to solve these. The fastest way to do it is to notice that if you could only just make this a negative 2, then the w's would fall out. So I'm going to only multiply the top equation times negative 2. That will give me a negative 270 equals a negative 12J plus a negative 2W. Second equation stays exactly the same. Add them together. I end up with negative 8J equals, this is negative 160. Divide by negative 8 on both sides, I end up with 20. So that means each case of juice costs $20. There's one of my answers. How much does the case of water cost? Looks like to me that it'd be easier to work with those first equations. So I'll say 135 equals 6J plus W. So I have 135 equals 6 times 20 plus W. So 135 equals 120 plus W. Minus 120 on both sides. I end up getting $15 for a case of water. So water is $15 per case. Next type of example we're going to deal with is money examples. So we might have things where we're dealing with part plus part and how many we have, and then we could have a number times the amount, and that would be our total amount. Much easier to go ahead and look at some examples. In this first example, Steve asked the bank teller to cash $390 as a $390 check using 20s and 50s. The teller gave him a total of 15 bills. So we've got two totals here, and I always like to find my totals. I've got the total of $390, and I've got the total of 15 bills being given out. I'll go ahead and call the X the $20 bills and the Y the $50 bills. So we are given so many $20 bills and a certain number of $50 bills. So we just have X plus Y. To get the $390, well, if you'd been given two $20 bills, that would be $40. So you're multiplying 20 times the number of bills you were given, plus the number of $50 bills you're given, you'd be multiplying that times 50. This one is going to be solved easily with elimination. Probably be just as easy to multiply everything times negative 20. So my first equation does not change. My second equation would read 15 times negative 20. Which would be negative 300. Negative 20x and negative 20y. So my x's cancel. I get 30y equals 90. Divide by 30 on both sides. That means I've gotten three $50 bills back. Looks like this one will be much easier to work with, so I'm going to pick the second one to do my substitution. And I'll plug 3 in for my y, subtract 3 from both sides, I get 12 for my x value. Remember, x was the $20 bills, so I'm getting 12 $20 bills. Last example of this lecture, and what it says is that to use a certain computer database, the charge is $30 per hour during the day and $10.50 per hour at night. If a research company paid $411 for 28 hours of use, find the number of hours charged at the daytime rate and the number for the nighttime rate. So I'll go ahead and use D and N. Well, we know there's two totals that use 28 hours of time, and it cost them $411. So I'll write those as my two totals. Those two totals equal something. The first total equals the total amount of money they paid. So it costs $30 for every daytime hour and $10.50 for every nighttime hour. The 28 hours is the total number of hours that they were using this database. So daytime hours plus nighttime hours. In this particular problem, I'm going to go ahead and by multiplying the second one times negative 30. So my first equation stays the same. My second equation becomes 28 times negative 30 would be negative 840 equals negative 30d plus negative 30n. When I add those together, I'll end up with negative 429. Those fall away, and this will give me negative 19.5 n. So I'll go ahead and divide 429 divided by 19.5, and negative divided by negative is still positive, so I end up with 22 hours. So at night, they used it for 22 hours, so this is night. Much easier to go ahead and plug that into the second equation. Plug in 22 for your nighttime hours, subtract 22, and we get our daytime hours to be 6.